Today we are diving deep into an important topic for building reliable APIs, model validations in ASP.NET Core Web API. Whenever you build public facing services, verifying incoming data is one of your most critical tasks. In this video, we will start with basic concepts, look at built-in validation attributes, see how to handle cross-property checks, and explore custom rules. Here is our roadmap for today. First, we will quickly remind ourselves how web APIs operate. Then we will break down why model validation is absolutely essential. We will follow a progression path starting with level 1 data annotations. Then we will check out the built-in magic of API control attribute. For complex scenarios, we will look at level 2 custom validations, level 3 cross property checks using IValidatableObject. Finally, we will explore level 4 enterprise validation using Fluent validation and see how validations fit into modern minimal APIs. If you are new here, don't forget to hit that subscribe button and turn on notification. Let's get started. Before looking at validations, what exactly is ASP.NET Core Web API? It's a modern cross-platform framework designed to build HTTP-based services. Think of it as a central bridge. Whether you have a React web app, a mobile application, or an IoT device, they all send requests to the central server. It provides an ideal framework for creating lightweight RESTful applications using C#. Let's visually see how a typical request flows through our API. A client like a mobile device or browser sends an HTTP request containing data to our ASP.NET Core controller. The matching action method processes the data, interacts with our database, our underlying services, and formats a clean HTTP JSON or XML response to send it back to the client. But ask yourself, what happens if the data sent by the client is broken, missing, or malicious? That is exactly where our main topic comes into play. The golden rule of backend development is never trust user input. We need model validation for four massive reasons. First, data integrity. It ensures bad data never corrupts our database tables. Second is security. It drops malicious payloads before they can exploit vulnerabilities. Third, user experience. It instantly returns actionable error messages so that client application knows exactly what to fix. And the fourth is separation of concerns. Your core business logic should not be cluttered with simple checks like making sure an email address contain @ symbol. It should assume incoming objects are already valid. Let's start with level 1 data annotations. This is the easiest, most common way to enforce validation rules in modern .NET. By pulling in the system.componentModel.data annotations namespace, you can add declarative tags right above your properties. It's fast, readable, and takes zero extra setup boilerplate. Out of the box, Microsoft provides built in attributes like required, string length, range, email address, phone, and regular expression. Let's see what this looks like in an actual code. Let's take a look at this model code snippet. We have a user registered DTO class. By adding the required attribute to the username property, we ensure the framework rejects null or empty strings. Below that, we combine it with string length. Usernames are between 3 and 20 characters long. For email, the built-in email address attribute validates standard formatting requirements. Lastly, we use a range attribute or age to restrict the regulations to individuals between 18 and 99 years old. Clean, descriptive, and very easy to read. Now let's talk about the magic of API control attribute. In legacy versions of ASP.NET, developers had to manually write tedious boilerplate code like if model state not equal to is valid, return bad request. Inside every single action method, if you forgot to write it, invalid data would slip straight through it. The modern way completely eliminates this. By adding API control at the top of your controller class, the framework automatically detects model validation failures. It immediately short circuits the pipeline and returns a structured HTTP 400 bad request using the globally recognized RFC 780 problem details format. But what happens when built in conditions like string length or range are not enough? That brings us to the level 2 custom validation attributes. If your enterprise requires specific custom formatting rules, like ensuring an email belongs to a specific corporate network domain, you can write a reusable attribute. All you need to do is inherit from the core validation attribute class and override its invalid method. Let's examine how this logic works in C Sharp. If you look at the implementation code below, we create a class named classic domain attribute that inherits from validation attribute. We override the invalid method, which gives us access to the incoming value object. We convert that value to a string and check if it ends with our corporate domain @company.com. If it matches, we return validation result.success. If that fails, we return a new validation results containing our targeted error message. Once this class is written, you can simply tag classic domain onto any DTO string property across your entire application. Now let's review level 3. Standard attributes work brilliantly, but they evaluate fields in absolute isolation. What if a rule depends on a two fields combined? For instance, ensuring a booking end date is always later than the start date. That requires level 3 validations via the IValidatableObject interface. By implementing this interface directly on your DTO class, your model can self-validate by executing a dedicated validate method that looks at all properties simultaneously. Let's check out the code. Look at this implementation for a booking DTO object. It implements the IValidateObject interface, which forces us to declare this validate method, returning an INMRable of validation results. Inside, we write a straightforward comparison check. If end date is less than or equal to start date, we have an invalid date range. We then use yield return to send back a validation results containing our error message, explicitly linking it to the end date property name. This ensures client apps knows exactly which field failed. Now let's get into the demo. Now I'm in Visual Studio. Let's create a new project. Let's select ASP.NET Core Web API. Let's call Model Validation Core Web API. Let's select Use Controllers and .NET 10. Click on Next. Let's create our own model called Certification. I'll create a folder called Model. In the model folder, let's create a model class. Let's create a couple of properties. We'll call ID. Now I created few properties for the certification class. Now let's go and add one controller. Let's take API controller empty, cert controller. Let's mark some data over here in the controller. So this is to get all certificates. So to test our model endpoints, we have to add a post. So let's put the post. So automatically we got the code here. Let me quickly enable Scalar to test the endpoints. In the program.cs, let's enable the Scalar. Let's launch the browser and give the URL as Scalar. Now let's run the app. The app is running at 7146 and you can see the Scalar UI. Let's go to the get call and you can see all our certifications are available, which is the mock data. Let's invoke the post call. Now it says name and category are required fields. That is coming because if you look at our code, here we are checking if this has null, it is returning bad request. What we will do is let's remove this validation. Let's rerun the app. As I removed the validation within the controller for the name and category, now we are able to post invalid data. Now with the model validation, how can we bring that back? Let's see. Let's go to the code. Now we will go and enable same validation over here. If you put the required attribute, now the same validation now we can apply on top of our properties instead of inside the controller. Now we'll say category is required. Now let's run the app. Let's the test the request. Now we are passing empty. Now if you see here, we are getting a 400 bad request. It says now name is required, category is required. This time instead of we checking manually whether the name and category are empty, automatically the model object is trying to check these annotations. Having API controller, it is automatically checking whether our model is valid or not. Now let's provide the name and category. Let's invoke the endpoint. Now if you see here, because these are required fields, now we are passing the data. Our model state is valid. Now it is able to successfully post the data. Now let's test other data annotations. So let's go to our certification model. So here let's put, this time we will say the string length. Let's make code as cannot be greater than 5 characters. On the category, let's put min length. Let's say that category should be minimum 3 characters. And also let's add a max length as well. And let's give 50. Maybe for the fee, we will say that the fee should be in the range of a number. So let's go and put a range. Let's call it as fee must be between 50 to $500. Now let's test this. Let's go to the post. Let's test the request. First one we will check the code cannot be more than 5 characters. So let's go and give. Now if you test this, it says code cannot be greater than 5 characters. It says name is required and the category is required. Now as we provided data for category is required is gone, but now it says it should be minimum 3 characters. Now if I put 3 more characters, that validation is gone. Now if you go and put more data here in the category, so let's go and put some data. Let me give a bigger category, more than 50 characters. Now let's invoke this. Now it says category cannot be more than 50 characters. Now it is trying to invoke all our validations. Let's go and extend few more validations. Now I have added few more properties. One is contact email. I'm saying check email address validation, and we are putting verify email address. This time we are saying go and compare with contact email. This validation will be invoked, and I'm putting an exam password, which is a regular expression, which is saying that the password should be at least 8 characters and this should be the combination. I put one more field called contact number, which is a phone number validation, and I put one more like credit card number. These are different annotations available to validate your model. Now let's go and invoke this. Let's put a post request. Now you can see the extended attributes here. Let's go and send a request. Name is required, invalid phone number. It says category is also required. and also it says contact email is not valid email address. So now let's go and let's put an invalid email address. I'll put some name, and if I put a wrong email, it says email is invalid. Now this time I'll say to make it valid, let's provide a category as well. Let's resend this. Now if you see here, now contact email validation is gone, but it says verify email address is wrong. So now we have to go and exactly give same as this. Now if you send this, now it says phone number is invalid. Let's give some phone number. Now all validations are successful. It is able to make the entry. Now let's test the password and credit card, as these are not required. That's why it's not invoking. Now let's give a wrong data. Now it says password must be at least 8 characters, and clearly it says it should be uppercase, lowercase, and a digit. And also here it says invalid credit card. Now we corrected the password. I'm trying to give invalid credit card number, and if you see it says invalid credit card number. Now let's go and give a valid credit card number. Now it says everything is successful. We got 201 created. Now all our validations are passed. Now let's check the level 4 validation with the validation attribute implementation. In that we go and validate two properties which are dependent, and we will invoke an validation error. So let's go and implement it. Let's add a folder called helper. Let's add a class. Let's call it as slot fee validate attribute class. Now let's go and implement. Let me get the piece of code here. Now we need to decorate this class with the attribute. Will try to apply at class level. Now if you look at the code, what we are trying to do is we are trying to take our certification model data. Here we are overriding the isValid method from validation attribute class. Because we are implementing at class level, the validation context will be our certification model, and we are saying that if the available slots are 0, if the certification is greater than 0, we are saying that don't charge fee if the slots are not available. Now let's apply this particular attribute on our model class. So let's go here. Let's say that slot fee validator. When you apply this attribute on your class, it automatically go and validate this particular method. Now let's go and run our model. Let's go to the post. Let's Now let's test the request. Let me post. But now what I will do is I'll go and make available slots to 0. Now if you see here, our validator is invoked. It says don't charge fee if the no slots are available. Now this custom attribute is invoked, and we are able to invoke this particular validation. Like this, you can go and add different annotations on your model properties. Automatically ASP.NET out of the box goes and checks your model state. If everything is valid, then only it will post the data to the server. With this we are done with the demo. Let's go back to the PPT. Now let's understand the limitations of data annotations. Up to this point, we have covered the native tools built in directly into .NET. However, as your application grow, data annotations start hitting serious limitations. First, they cause mixing of concerns. Your DDO classes should be simple data structures, but they get cluttered with endless validation rules and hard-coded error messages. Second, they can't handle complex dependencies. If you need to check a database to see if a value is unique, trying to inject a database context into a custom validation attribute is incredibly messy. Lastly, they struggle with conditional rules such as requiring a postal code only if the country field is set to USA. To solve these challenges, we are going to use level 4 fluent validation. To build clean enterprise grade APIs, we step up to level 4, which is fluent validation. It is a popular industry standard open source library that solves all the limitations we just discussed. It keeps your DTO completely clean, meaning they remain naked C# classes without validation attributes cluttering them. Instead, you define your rules in separate dedicated validator classes using a fluid, strongly typed interface via method chaining. The separation makes your code remarkably maintainable and incredibly easy to unit test. I will cover more details on fluent validation in my upcoming videos. As you explore modern .NET development, you will encounter minimal APIs. An important catch here is that minimal APIs don't use standard controllers, meaning they don't get the automatic 400 bad request behaviors provided by the API controller attribute. If you pass an invalid object, it will bypass validation checks out of the box. The modern solution to this problem is using endpoint filters. These filters let you intercept incoming request payloads right before your route handler runs. You can write a single reusable generic endpoint filter that runs fluent validation rules across any endpoint automatically. Let's wrap up with our architectural best practices checklist. Rule number one, always validate DTOs, never domain or database entities. Keep your incoming request cleanly separated from your data storage models. Use basic data annotations for fast prototyping or internal validation constraints that never change. However, for production microservices, conditional logics, or database backend checks, adopt fluent validation to keep your code clean and maintainable. Finally, make sure all your validation formats map back to standardized problem details responses so your client applications have a consistent experience. That covers our complete implementation of model validations in ASP.NET Core Web API. Thank you so much for watching. If you found this video helpful, please give it a thumbs up, share it with your fellow developers, and subscribe to .NET channel. For the full source code, refer to my GitHub. I will provide the link in the description. See you in the next video. Thank you for watching.